Hello, I'm Dylan Batten, and this is my remotely controlled, bio-commanded, servo-actuated robotic hand, or I like to call it my mimic hand. It'll get there. Right now. Some time ago, I was fortunate enough to be working with someone who came across this 3D printable arm. Designed by a French artist, Gaël Langevin, who can be found on the website inmove.fr for France. That's inmove with 2 O's and no E. As soon as I saw it, I thought I had to have one for myself. So I 3D printed this hand. And after seeing its movement profile, I immediately wanted to control it with my own hand. So I thought, okay, I can do this. I can build a glove that's wired to an Arduino, because they're easy enough to work with, that uses some kind of sensor that when my hand flexes, it can send the appropriate signal to the Arduino and relay that to position information to the hand. Well, here I have a glove. I decided that if I could find some flexible resistors, because I am familiar with something called a strain gauge, which is just that, a resistor that changes resistance according to a strain put on it. In this case, the strain is the flexing of my finger, and I've seen some very rigid strain gauges, so I thought, I wonder if I can find some very flexible ones that will last a while. And I found just that. I found some 15 and 25 kilo ohm resistors that are very flexible and very durable and not expensive. And I had a bunch of elastic straps from another project. So I took the elastic and I sewed it into the glove, and then I glued the sensor tip to the glove, ran it through the channel, and connected the leads. In the spirit of keeping it simple, I then made a voltage divider circuit. Now, frankly, it's kind of a mess, but I have it here. Waka 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 waka. So here we have the 2 circuits. On the left is my arm, or the biological arm, and on the right is the robotic arm, or the machine arm. On the left is the voltage divider circuit. It is 2 resistors in series, powered by the Arduino at 5 volts. One resistor is a fixed 10 kilo ohm resistor, and the second is the flexible sensor or strain gauge that is sewed in to my glove. In between them is this node is the sensor pin that is connected to the analog input pins in the Arduino. This will measure a change in voltage due to the change in resistance when I flex or extend my fingers. On the machine side, we are controlling servos. The position information of the servos is based on the position information read by my fingers. What you are seeing here is a future state where there is two wireless modules, one connected to my own arm and one connected to the machine arm. Currently, the sensor side and the control side are connected to one Arduino. This is very limiting, which is why I will be moving to a wirelessly controlled system. And in real life, it's all right there. I'm using a power supply right now instead of a battery, hooked up to some power rails. But the Arduino is a mess of wires, which is why I want to upgrade it. But basically I use the breadboard for the voltage divider circuit, and the analog pins to read this, and the digital PWM pulse width modulation pins to do that. And it's super cool. My code is on GitHub, and I'll leave a link. More to come. Thanks for watching the short video. Peace.